Now, in this short lecture, I will give you a proof to the Pythagorean theorem. The Pythagorean theorem relates to a right angle like this. The Pythagorean theorem relates to a right triangle like this triangle that has one angle that is 90 degrees, and it claims that the square of the hypotenuse, that is side C, is equals to the sum of the squares of the perpendiculars, that is a squared plus b squared, or c squared equals to a squared plus b squared. Actually, in order to prove the theorem, we built a copy of this triangle here. We built it by actually, first of all, we built the on side B, we built line side A. So B and A are on the same line, on the same straight line, and then we raised a perpendicular to side A in size of B. So here we have 90 degrees because B is perpendicular to A. So here, as you can see, side A in the right triangle equals to side A in the left triangle, and side B in the right triangle equals to side B in the left triangle. And also the angle between side A and side B in the right triangle is equal to the angle between side B and side A in the left triangle. That is to say, it is 90 degrees. Okay, so here actually we have two triangles that equals in two sides. A equals A in the right triangle equals to A in the left triangle, and B in the right triangle equals to B in the left triangle, and also they have the same angle between side A and side B. It is 90 degrees. We have 90 degrees between side A and side B in the right triangle, and we have also 90 degrees between side B and side A. For that reason, the triangle in the right side coincides to the triangle in the left side, because of the fact that if we have two triangles that have two equal sides and also the angle between those two sides are equal, then those two triangles coincide to each other. So triangle, the right triangle in the right side coincides to the left right triangle, and now we will name the angle between side A and side C as alpha. Okay. And so also here the angle, because of the fact that these two triangles are coincides to each other, the angle between side A and side C will be also alpha, of course. And also we know that in every triangle the sum of its three angles equals to 180 degrees. Suppose that this angle is, we don't know what this angle is, so we will label it as x, we will name it x. So we know that alpha plus 90 degrees plus x equals to 180 degrees, because in every triangle the sum of its angles equals to 180 degrees. So we can write that alpha plus 90 degrees, this angle is 90 degrees because it is a right triangle, plus x the unknown angle, equals to 180 degrees. It is correct for every triangle in the world. The sum of the angles of every triangle on the world is 180 degrees. So we can say that alpha plus 90 degrees plus x equals to 180 degrees. Now we also label the angle between side C in the right angle to side C in the side C in the right triangle to side C in the left triangle. We will name the angle between those two sides as y. Okay, but first of all, we will find what is x. Alpha plus 90 degrees plus x equals to 180 degrees, as I showed you. So we will subtract 90 degrees from both sides of the equation. So we will get that alpha plus x equals to 180 degrees. Okay, we subtracted 90 degrees from both sides of the equation. We get that alpha plus x equals 1 minute, I made a mistake. We subtract 90 degrees from both sides of the equation, so we will get that alpha plus x equals to 90 degrees. As you can see here, we subtracted 90 degrees from both sides of the equation, so we got that alpha plus x equals to 90 degrees, and finally x equals to 90 minus alpha. X equals to 90 degrees minus alpha. Okay, x equals to 90 degrees minus alpha, so we can write here that x equals to 90 degrees minus alpha. We know that in every straight line the sum of the angles on one side of the straight line is equals to 180 degrees. If you make the sum of the angles in both sides of the straight line, it will always be 360 degrees. But if you make the sum of the angles in one side of the straight line, you will get 180 degrees. So we can say that x plus y plus alpha equals to 180 degrees. It is on one side of the straight line. Okay, so x plus y plus alpha equals to 180 degrees. Okay. Now we know that x equals to 90 minus alpha. So we will substitute x by 90 minus alpha plus y plus alpha equals to 100. So here we substitute x by 90 minus alpha. So minus alpha plus alpha equals to 0. Minus alpha plus alpha equals to 0, so we left with 90 plus y, 90 degrees plus y equals to 100 degrees. We will subtract 90 degrees from both sides of the equation. So y equals to 90 degrees. Okay, y equals to 90 degrees. So the triangle in the middle, this triangle is a right triangle because here we have 90 degrees, right angle. Now, as you can see here, we have a trapeze. This is a trapeze, and we will calculate the area of this trapeze in two ways, and then we will compare the results. Of course, they are equal to each other, and from this comparison we will get Pythagorean theorem. Okay, so the first way to calculate the area of this trapeze is, we can say that the area, we will call the area of a trapeze as S. Okay, so the first way to calculate the area of this trapeze is, the area of the trapeze is the sum of the parallel sides, A parallel to B, so it is the sum of A and B, times the height of the trapeze. The height of the trapeze is also A plus B, divided by 2. So we calculated the area of this trapeze in the first way. The area of the trapeze is equals to the sum of the parallel sides, that is A plus B, plus times the height of the trapeze, that is also A plus B, divided by 2. Okay, now we will calculate the area of the trapeze in a second way. We can say that the area of the trapeze is actually the area of the components of the trapeze, and this trapeze contains three triangles: the left triangles, the middle triangles, the right triangles, the middle triangles, and the left triangles. So the sum of the areas of the right triangle plus the area of the middle triangle plus the area of the left triangles will be equal to the area of this trapeze, yes? So what is the area of the right triangle? The area of the triangle is its base times the height to the base divided by 2. So the area of this right triangle is b times the height, that is a, divided by 2. What is the area of the middle triangle? The area of the middle triangle is the base of the triangle times the height to the base divided by 2. So the base of the triangle is c times the height of the triangle is also c divided by 2. And the area of the left triangle is the base of the triangle times the height. The base of the triangle is a. Its height is b divided by 2. So at the end we got the area of the trapeze. We calculated it by calculating the area of the three triangles that the trapeze consists of. The trapeze consists of the right triangle, the middle triangle, and the left triangle. So the sum of the areas of the three triangles is equals to the area of the trapeze. So in total we got that the area of the trapeze in the second way of the calculation is b times a divided by 2, that it is the area of the right triangle, plus c times c divided by 2, it is the area of the middle triangle, and a times b divided by 2 is the area of the left triangle. So the sum of the areas of the three triangles is equal to the area of the trapeze. Okay? Now we will compare the two results. It is the same trapeze, so expression 1 is equal to expression 2. So we can write that the area in the first calculation is equals to the area in the second calculation. So a plus b times a plus b divided by 2 equals to a times b divided by 2 plus c times c divided by 2 plus a times b divided by 2. Okay? The first expression equals to the second expression, that is the area of the trapeze in two different ways. So they are equal to each other. Now we will multiply the two sides of the equation by 2, and then we will get that a plus b times a plus b equals to a times b plus c squared plus ab. Okay, so we multiplied the two sides of the equation by 2, so we got a plus b times a plus b equals to ab plus c squared plus ab, so ab plus ab is 2ab. Okay, ab plus ab is 2ab plus c squared. Now we will open the brackets of the left side. So a times a is a squared plus a times b is ab, b times a is ba, and b times b is b squared equals to 2ab plus c squared. As you can see, here we opened the brackets in the left side of the equation. A times a is a squared, a times b is ab, and b times a is ba, equals to 2ab plus c squared. Now ab plus ba is 2ab. ab plus ba is 2ab, so we have in the left side of the equation a squared plus 2ab equals to 2ab plus c squared. Now we can simply deduct from the both sides of the equation the expression 2ab. And actually, finally, we will get the Pythagorean theorem. Here we deducted from both sides of the equation the expression 2ab, so we left with the expression a squared plus b squared equals to c squared. That says that the square of the hypotenuse equals to the squares of the perpendiculars in the right triangle. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, and that is exactly the Pythagorean theorem. So actually we can summarize what we did. Actually, first of all, we built a copy of this right triangle. We built a copy of it in the left side, and then we calculated the angles between B and C and the angle Y, and then we have here a trapeze, and we calculated the area of the trapeze in two different ways. and then we compared the two results. Actually they equal to each other, and from this equation we got the final result of the Pythagorean theorem that says that the square of the hypotenuse in the right triangle is equal to the sum of the squares of the perpendiculars. Okay, I hope that you enjoy the lecture and you actually understand it. Okay, thank you very much.